So hello and welcome everyone. My name is Jay Dalsaniya and in this video we are going to solve the question remove half nodes. So this question is quite easy, okay, and you just need to know in binary tree questions or let's say BST questions, you just need to identify which traversal technique will help you to solve that question. And this question is the best example to teach you how to identify the traversal techniques, okay. So without wasting any time, let's start the video. And if you are really enjoying this video solutions, then do hit the like button and write down your approaches in the comment section below, and also uh, give the feedbacks on how you fill the editorials. Okay, so let's start. So you are given a binary tree and you need to remove all the half nodes. And the definition is the half node basically is a node which has only one child. Return the root node of the modified tree after removing all the half nodes. And there is a note, the output will be judged by the in order traversal of the resultant tree inside the driver code. Okay. So let's take the first example that is given over here 5, 7, 8 and 2. And the given binary tree is not a BST, it is simply a binary tree. So 5, 7, 8 and 2. So in this binary tree 5, 7, 8 and 2. So this is our binary tree input number 1, let's say. Now I am supposed to find out the half nodes. I am supposed to find out what are the half nodes over here. So what can I understand by half nodes? So in the question, the definition of half node is a node that has only one child. So over here 7 is a half node. What about 8? 8 does not have any child node. Okay, so half node basically has got only one child node, so 8 is not a half node. What about this 2? 2 is also not a half. Okay, so if I remove this 7, what will happen if I remove this 7 from here? So the updated binary tree will have 5 and all the remaining nodes as it is 5, 8 and 2. Okay, so in place of 2, its child has been placed, that is 2. So this is the output tree and the output will be judged by the in order traversal of this binary tree. You are supposed to return the root of the modified tree. Let me give you some other examples also so that you can understand it in a better manner. Let's say 5, 7, 2, 3. Let's take 6 and let's take 4 over here. I'll take 15 here, 9 and let's take 8 and 6. Okay, so I have taken a random binary tree and now I'm supposed to basically remove all the half nodes. So first of all, identify the half node. I can see 2 is a half node. I can see 6 is a half node. I can see 9 is a half node. It has got only one child node, right? And do we have any other half nodes? No. So if I remove this 2, what will happen? What do you think? If I remove this 2, 3 will be appended over there, right? At that position, 3 will be placed. So let me just draw out the output tree. How will it look like? Okay, so here I will remove this 2. So in place of this 2, 3 will be placed and this 3 has been given a higher position. So 6 will also be removed. So in place of 6, 4 will be placed and this 4 has been given a higher position, so it will be removed. And in place of this 9, 8 will be placed. So let's delete this 9. Okay, and I will be placing 8 over here. So this 8 is got a different position now. And this is our updated binary tree. Okay, so I hope you got an idea like what should be the output. So for this given output, for this given test case, this is our output 5, 7, 15, 3, 4, 6 and 8. Okay, so I hope you got an idea about what the question is. Now let's try to understand how to solve this question. Okay, so the question is saying that you are supposed to remove the half node. So what I will do, I'll categorize the nodes. So we know that there are something called as half nodes and we are supposed to get rid of this half nodes. Okay, then what can we have? Then we can have leaf nodes inside a tree, right? So we are not supposed to return the leaf, we are not supposed to remove the leaf nodes. They are supposed to be kept as it is. And what about the other types of nodes like 7? What is this 7, 5 which has got both the child nodes? Let's call them full nodes. So let's call them full nodes. So now here I am supposed to return or basically delete this category, that is half node. So now I'm supposed to identify which node is a half. Okay, fine. So how will I be able to identify whether a node is a half node or not? Okay, so we know that there are different traversal techniques. We have in order traversal, that is L, D and R, and D basically denotes the root node, right? So we have in order, that is basically L, D and R. So we have pre-order, then we have post order traversal. Post order is basically L, R and D. Okay, so now here I am supposed to identify the category of a node. Okay, so we know that half node basically will be having only one child node, leaf node will be having zero child nodes, and full nodes will be having how many child nodes? Two child nodes. Now tell me, for a given node, how can you identify? Which traversal technique will help you to identify the number of child nodes present? So obviously, if you want to know the child nodes, how many child nodes are present, you need to explore the left subtree and then the right subtree. Then you will be able to identify that for this particular root node, how many child nodes are present, right? So what is that kind of traversal technique? You need to explore the left subtree first of all, then the right subtree, so you can identify that left and right child are present, and then you can say that this root node is a leaf node or a half node or a full node. So that traversal technique is what? It is our post order traversal. You traverse the left subtree, right subtree, and then the root node. So here I am going to identify the category using the post order traversal of a particular node. Okay, and for this half node, what I am going to do, basically I have to delete this half node, right? So whenever I identify that this current node is basically is a half node, what I will do, I will be either having one of the child node, right? I might be having, let's say I have a half node, that this is our half, so I might be having the left child or I will be having the right child. Anyone can be there, right? So what I will do in that scenario, for this kind of recursion, I will not return the root node. What I will do, I will return the not null child, whichever is the child and which child is not null, I will be returning that child. Okay, so now let's do a quick dry run on what this approach is all about. So I'll take this input number 2 and I will show you the dry run. Okay, so we will be identify that what is the category of a particular node. So here I will be using a post order traversal, and we understood why we are going to use the post order traversal, because we need to know the count of the child nodes. And here is basically the different types of categories of nodes: half node, leaf node, and the full nodes. Okay, and here we are going to use the post order traversal, that is LRND. Okay, so let's start the post order traversal. So it will say move to the left. So this is, let's say this is my current node, it says move to the left, move to the left, and move to the left. And now this is my current node, so it will move in the left hand side. It will get to know that this is a null node. So it will be knowing that if my current is basically what, let's say 2, its left child came out to be what? Null. Now it will make a call to the right hand side, right? So right child is not null for 2. So now tell me, how many child nodes does this 2 have? 2 has got how many child nodes? It has got only one child node. So this is a half node, right? So now tell me, what should be the left child of 7? Should I keep 2 or should I delete this 2? Now if you are deleting this 2, 3 becomes the left child of 7, right? So now whenever I return something to this 7, what I will do, I'll not return this half node. I'll return the not null child. So 3 is not the null child, right? So I'll be returning 3 from here. So 2 will be returning what? It will be returning the reference of this child node 3. And here what will happen, when this 7 is receiving 3, it will make a call again. It will make a call to what? It will make a call to this right child of 7. So it will make a call to 6. Here again the post order traversal will take place. So 6 will be making a call to this 4. Okay, so now current node is what? Current is basically 6. The left child is what? It is not null. Okay, now what is the right child of this 6? Right child is basically null node. Okay, so now tell me, what is the category of this 6? So I got to know that 6 is basically our half node. So now when 6 is returning something over here, it returns something to this 7. What will it return? It will return the reference of this not null child. It will return the reference of this 4. Okay, so now 7 will make some updations. Okay, so what is your current node now? Current node is basically 7. Now what is the left child? It is not null. Okay, and it has been returned something. So left child has been returned by this recursive function. And what about the right child? Right child is also not null. Now 7, whenever they get to know that from the left subtree I have received some reference and from the right subtree I have received some reference, what will this 7 do? What will this full nodes do? It will basically update its left and right child by whatever references have been returned by the left subtree call and the right subtree call. So now 7 will say, I will not consider this 2 as my left child. I am going to consider the returned value. It will consider the node 3 as its left child, and similarly it will consider the right child as not 6. It will consider the right child as the returned value, that is 4. So now here you can see, now this is the updated tree that I am showing you over here. So 2 will be gone from here, 3 will be gone. Okay, basically they are the references, so it will get updated. Now here you will observe 4 is present and here you will be observing 3 will be present. Okay, So for the full nodes, you are going to update the reference of left child and right child, and for the half nodes, you are supposed to return the not null child reference. Okay, so moving on forward, so for 7 the post order traversal is completed. So now here it will go back. So current node will be what? So current node, now again it will be 5. And now let me just delete these things because we are done with this part. Okay, so current node is 5. So we made a call to the left of 5. Now we should make a call to the right of 5. Here also post order traversal will take place, so it will make a call to the 6. Okay, and when 6 is completed, so again it will make a call to what? Now your current node is basically 6. Its left child is what? It is null. Okay, and what about the right child? Right child is basically null over here. Okay, so now what is the category of this 6? Now 6 will be encountered. I can see left child is null, right child is null. So now whenever you see both the children are null for a given tree, you can identify it as a what? It is basically a leaf node. So in case of leaf node, it will just return its reference back to the parent. Okay, so 6 has returned 6 to its parent. Now left of 15 has been explored. Now right of 15 needs to be explored. Okay, so now current node is basically what? Current node is basically 9. What is the left child? So it will make a call. Left child is not null, and as we can know that this is a leaf node, it will be returning itself. So it will be returning 8, and when it makes a call to the right child, it encounters that right child is basically null. Now from this, what can you say about this current node? Is it a half node, leaf node, or full node? It is a half node. It has got only one child. So what will this half node do? It will return the reference of not null child. So not null child is what? 8 is not the null child. So it will return the reference of 8. Now 15 got a response from the left child at left subtree, that is 6, and 15 got a response from right child, that is 8. So it will update its left and right child. So this left child will be updated by 6 itself, the same reference again, and this right child will be updated by this new node, that is 8. So it will update the left right child with the new node, that is 8. Okay, because that is what it got. Now here again coming back, so 15's left is complete, right is complete. Now 15 needs to be encountered. Okay, so now here you can see this 15 basically is a full node. So 15 will be returning its reference, and this 7 also returned what? It returned its reference. Now 15 will update its left child with 7 again, because it is a node that has been returned, and 5 will also update the right child as 15. Okay, and that's it. And finally this 5 will be returning itself because it is a full node. So in this manner, the post order traversal will help you to remove all the half nodes, and whenever you see a half node, just return the child that is not null. Don't return the root node itself. So that's the catch over here. And now I guess we are good to go, and we can code, have a look at the implementation part of for this. So here is the solution which we have written over here. I have written the code in Java, but I will help you with any other implementation as well. Okay, so remove half node. We have to complete this function. I have used a condition that if my root is null, basically I should return null, right? Now I'm making a call to the left child and then the right child. And here you can see I have directly updated the root.left and right.left at this point itself, because I am going to refresh the left and right child for the current node, okay, every time. So I'm just updating over here, whatever this left subtree will be returning, whatever the right subtree will be returning, I'm updating the left and the right child accordingly. Now I'm identifying what is the type of my current node. Okay, so I'll check if this is a leaf node, I will get to know that the left child and right child, the updated ones also will be null. So if they are null, I'll be returning the root node. Now I'll be identifying the half node. If the left child is null and the right child is not null, then I am going to return the not null. So root.right is not null, so I'll be returning the right child. Now here, if the right child is null and the left child is not null, I'm going to return the not null, that is left child. Okay, and if I see that both the left and right are not null, so that means it is a full node. So in the full node, I am going to return the root node itself. Okay, so that's pretty much. And now let's say to submit it and let's see the acceptancy of it. Till then, we can discuss the time and space complexity over here. So I can see that if I see the entire binary tree having n nodes, then this entire approach is a post order traversal, right? So it will be taking around order of n as your time complexity, and about the space complexity, the recursion will be taking or occupying some space, and the recursive space will be order of height of the tree. Okay, so this is our time and space complexity for the question remove half nodes, and we can see that the problem has been successfully submitted. So that was it for in this video. I hope you really enjoyed this solution, and if you really enjoyed this solution, do hit the like button and share down your approaches in the comment section below. So that was it for in this video. I will be seeing you in the next video. Till then, keep coding.